Today we're looking at finding the volume of pyramids and cones. Let's look back at some 2D figures first. Here I have a rectangle with base and height. If we know the area of that rectangle is base times height. If I inscribe a triangle within there, what would the area of that triangle be? Of course you remember, it's half as much. Now let's look at a 3D image. Let's say I have a cube. And that cube has a base. We know the volume of that cube is going to be its base times its height. Now if I inscribe a pyramid within that cube with the same base and the same height, what do you think the volume of that pyramid would be? So in order to answer this question, I want you to follow this link to a video someone else created. So pause this video and then click on this link, and you'll be able to see how many pyramids fit into this cube. So you can see from the video that the volume of the pyramid is not going to be half as much like it is in 2D. It's going to be a third as much, which is sort of interesting. Why is it a third as much? Well, if we go and we look at, say, the volume of a triangular prism, now that would be half as much. So it makes sense now that the pyramid's going to be less than half, because you're not only losing the sides, you're also losing the front and the back volume. And it sort of makes sense that it's going to be less than a half, but it turns out it's exactly 1/3. Another activity we could do is cut out some two-dimensional nets that would fold up into triangular pyramids like this. These are called Yangma. And if you fit 3 Yangma together, it makes a perfect cube. It's sort of like a little puzzle box. Obviously, this isn't going to be possible now, but you know, you could probably find this online somewhere and do it yourself if you wanted to. So we've seen that the volume of any pyramid and cone is 1/3 the base area times the altitude. The only thing that changes, once again, is what kind of base you have. So if you have a square base, it's going to be 1/3 length times width times altitude. If you have a cone, a circular base, it's going to be 1/3 pi r squared altitude. So why don't you see if you can find out which has a greater volume, a half cylinder or a cone. There are no measurements here, so you'll just have to do it with variables. Assuming they have the same radius, the half cylinder would be 1/2 pi r squared altitude. And of course the cone is 1/3 pi r squared altitude, so obviously the half cylinder is going to have greater volume. You might want to pause the video here and try to answer these two questions. 1/3 base area times altitude. For the square pyramid, it's going to end up with a volume of 384 cubic units. For the pentagonal pyramid, it's going to be 120 cubic units. Take a moment and find the volume of these two figures. Always start by writing the general formula. Here you're going to have to find the area of the base. You know it's a circle, so pi r squared will be your base area. And the radius is 2. The height, or the altitude, is 5. That gives you 20 pi over 3 for the volume, which you can estimate. For the, looks like that's a triangular pyramid, you're going to use half the base times the height to find the area of the base. Your base and height are both 4, and the altitude is 4. So this is going to come out to be about 10.67 cubic units. I've seen this question on a lot of exams. SAT, I saw it once. I've seen it on the ACT. Just asking you to compare the volume of two figures that have the same base and the same height, one being a cylinder, one being a cone. They just want to see if you know that the volume of the cone is going to be 1/3 as much. If we plug in the numbers and do some substitution here, you can see that the volume of the cylinder is 300 pi, and the volume of the cone is going to be 1/3 as much. And then finally, why don't you pause the video here, see if you can find the volume of this silo. Obviously it's a cylinder plus a cone, and the cylinder formula is just base times altitude. And we'll do some substitution. The radius obviously is 6. The cone is going to be 1/3 the base area times the altitude. Same radius, different altitude, 8 instead of 30. And you're going to add these together. So it's going to come out to 1176 pi. And here is your suspicious mistake of the day. Have a good one. Talk to you soon.